Hello everyone. In this video, we are going to talk about the array implementation of stacks. So in the previous video, we saw how stacks work, the basic operations of stack, which were, if you could recall, those operations were push, pop, empty, and top or peak, whatever you may call this. So these were the four basic operations of stack. And then we also talked about an additional operation, which was size. So in this particular video, we'll be talking about how do we implement all these operations and how do we implement a stack in general using arrays. So without any further delay, let's just start. So the basic idea over here is that we'll be using a dynamic array which will be allocating some size, a fixed size for the stack. So let's say we have this particular array over here, which is of size how much? 1, 2, 3, 4, 5, 6, 7, and 8. So we have an array of size 8, which will be, if you talk about the exact size of it, so let's consider that this is an array of integers. So one particular integer will take up 4 bytes of memory. So this will be in total 32 bytes of space, which we have allocated for the stack. Or you can just say in simple terms, 8 blocks of memory, 8 continuous blocks of memory in the form of array, right? So now we also talked about a concept known as a top pointer, right? So this is basically the pointer through which we'll be accessing the various elements of our stack using this array. So initially what will happen is that this top pointer will be pointing to an index -1. Right, this is not an element, but this is rather an index. You can write it over here. So it will be pointing to an index -1, which means that the stack is empty at this particular instance. Stack is empty. So if the top is pointing to -1, it basically means that the stack is empty. There is nothing in the stack as there is no elements present in the array. And initially in the array, what we have are garbage values, right? So we have something over here like, let's say 1, 2, 3, 4, anything. Like initially when you declare an array, it is filled with garbage values, right? So now let's see what can we do when we want to perform a push operation. So we have this our stack. Let's just denote this small bucket as our stack, and we want to push in a number, let's say 1. So how do we do it using this array? So like I said, to access or to modify any element, we'll be using the top pointer. So if we want to insert this particular one, we will be first incrementing the top pointer. So the top pointer will come over here and will point to the 0th index of the array. And this operation will be nothing, but you can say as top plus plus or plus plus top, depending upon whether you are doing a post increment or a pre increment. So this will be the operation, and we'll be incrementing the array, the top pointer to point at the 0th index, and then we'll perform an operation which will be something like, let's call an array at ARR, or array as ARR. So it will be like array at top equals to whatever the element is which we want to insert. Like at this particular moment we want to insert 1, so it will be equal to 1. But in general, if let's say we have to insert something as x, so it will be something like this: x array at top equals to x. So what we first did, we first incremented the top pointer, which was nothing but top plus plus, and then we did array at top equals to x, right? So let's say we inserted one over here, and in a similar fashion, uh, let's say we again incremented this top pointer to come over here, and we inserted. So currently we have a 1 in our stack, and let's say we inserted a 2 in the stack. So we had 2. Similarly, we came over here. Let's say some random element we inserted 7, 7, and our stack is still not full. Like we have space. So and then again we came over here. The top pointer came over here, and then we let's say inserted 8. So we have 8 in our stack. And in a similar fashion, we keep on incrementing the top pointer and inserting elements. Let's say 3, 4, 6, and 5 until we reach the end of our array. So after 8 we had 3, 4, 6, and 5 inside of our stack, right? And now if you carefully observe, the top pointer is currently over here. So if we try to actually access the 8th index of the array by doing a top plus plus, so the top pointer comes over here, we do a top plus plus operation, the top pointer comes over here, and we are trying to access the 8th uh, index of the array, we'll be getting an error. Why so? Because our array is already filled with elements, and we initially declared the size to be just 8, right? So we had the last index. If we do a zero-based indexing, which is generally done in languages such as C++ and Java, there is a zero-based indexing. So the last index which we land upon is the 7th index. So we definitely cannot access the 8th index. So this is the condition uh, which will give you an error, or throw you an error, and you will end up in the condition which we discussed in the previous video, which is a stack overflow error, right? Stack overflow. So we need to make sure before incrementing the top pointer that our top is not currently pointing to the last index. So in this case, the 7th index. Or in general, if let's say we declare an array of size n, so we need to make sure that if the top equals to n minus 1, which is nothing but the last index, so if we have a size of 8, so n minus 1 will be 7. So we need to make sure that before performing the top operation, we just check that top is not equals to n minus 1 already, because if it is, then on the next increment the top will go to n, and we cannot access array at n, right? So this was about the push operation. Now let's move on to the pop operation. So suppose let me just clear all this. Yes, so suppose that we inserted all these elements up till 5, and currently we have a top pointer over here, right? Now remember what I said at the very beginning, or what I have been saying until now, that we can only access the elements of the stack using the top pointer itself. Like there is no other way in which we can access the elements apart from using the top. So what if we want to pop an element? Do we actually need to delete this particular memory from the array? The answer is simply no. What we can do is simply decrement the top back, top minus minus, right? And our top will come to this particular position, and it will be gone from here. So you might be wondering that, okay, we are on 6, and you are saying that we have popped this 5 out of our stack, but this 5 is still present in the array, right? This might be a genuine doubt which might come up. So the thing is, like like I just said, that the only method through which you can access the elements of a stack is using the top pointer. So it doesn't matter what is there uh, in the array apart from the element which the top is pointing to, whatever is there in the array, we don't care about it. We only care about that particular element which our top is pointing to, which is 6 at the current moment. So although this 5 is still there in the array, it is gone for our stack because the top pointer cannot access this 5. And definitely we cannot access an element of the stack by something like doing something, some operation like this, like array of 7. We cannot directly access elements or stack in this particular manner like we do in the arrays. So we cannot randomly jump upon any index and just check the value or allow the user to do anything as such. Like the user should not be able to do array at 2 and get the element at the second index, which is 7. So we can only access it using top pointers. This is a very important concept to keep in mind. So suppose we again want to pop our element. So let's say we want to pop 6 as well. So like we'll simply do another pop top minus minus. So our top pointer will come over here. And the 6 will be gone for us. Although it is in the array, but for us it is gone. And for the stack it is gone because we are only accessing through top pointer. And now suppose I wanted to insert another element, let's say 7, on top of this 4 after this 4. So what I'll do, again I'll follow the same fashion which I talked about push. Like we'll first increment the top, so the top will come over here. So we'll do a top plus plus, and then we'll do array at top equals to x. X is that particular element which we want to insert, which is 7 in this case. So this 6 will be overwritten with 7. And now our new stack becomes 1, 2, 1, 2, 7, 8, 3, 4, and again 7. So yeah, so like on top of this 4, 7 will come up. So I hope you got a basic idea about the push as well as pop operation. And now one more thing to keep in mind while doing pop operations is, obviously, like we talked in the previous video as well, the stack underflow condition. There might be a condition where there is nothing to pop in the stack, but still we are performing the pop operation. So we are currently on the 6. We did a pop. We popped this 6 out of the stack, and then we came on 4. And then again we did a top minus minus, which is nothing but a pop operation. Then we came on to this 3, and then in a similar fashion to 8, then to 7, then to 2, then to 1. And finally, after this 1, when we pop this 1 off our stack, so everything is gone from the stack. So basically, it is something like this, like everything is gone from the stack, and the stack becomes empty again. And after, like for popping this one, the for popping this one, the top will be over here, and we'll be doing a top minus minus. So now the top is currently 0, and after the top minus minus operation or the decrement operation, the top will again point back to -1, which essentially means that the stack is empty. So now we cannot again do the pop operation over here. Like we cannot do top minus minus again over here because already our stack is empty. So like when we are on the 0th index, we need to make sure before popping, we need to check a condition like if top equals to 0, then or maybe if the pop is equals to -1, not 0, because -1 means that the stack is empty. So if the top is already at -1, uh, if we try to pop, we instead of popping, like instead of doing some operation here to pop, we have to throw an error over here, like maybe print a statement which says stack underflow, right? Like it says, let me write it clearly. So stack underflow, like we discussed in the previous video, like what stack underflow actually is. So if you haven't watched that part, you can go back to that video and refer it from there. So yeah, this was all about pop. And now coming to empty. So this is very simple. Like I just said repeatedly, that if the top is pointing to -1, the stack is essentially empty. So this is all about empty. Like we just check whether the top is -1 or not. So empty will be a Boolean function. So what will happen is we'll simply return top equals to -1 or not. So what will this will check is this will check if the top is -1. If it is, it will return a true. If it is not, which the true means that the stack is empty. And if there are some elements, then the top will definitely not be -1. Like in this case, the top will be 0, 1, and 2. So the top will be 2, but we are comparing with -1, so it will return us a false, which will tell us or indicate that the stack is not empty. So true will be nothing but a 1, and false will be a 0. So yeah, this was about empty. And now coming to the top or the peak operation, in which what do we do? Like we see the element which is currently being pointed by the top. So yeah, so this is also a similar thing. If we just have to return the array at top, like that particular element which is currently being pointed by the top. So like suppose if we have the top over here, so it will return the array at top, that is array at 2, which will be 7. So this operation will just return us a 7, right? And in this also we have to make sure that if the top is at -1, so we have to write an if condition before this to make sure that the top, if the top is at -1, we throw an error. We should not allow the user to access the garbage value. There will be some garbage value at -1, so that value at we won't be allowing the user to access that. So we'll just throw the similar kind of error, which will be a stack underflow error. So yeah, this was about the top and peak operation, top or peak operation. And now coming to the size operation. So this is very simple again. Like suppose I have my top. Let me just clean up a bit. So yeah. So let's say I have my top pointer currently over here. So what is the size of the stack currently? We have 3 elements, 1, 2, and 7. So the size is 3. So how do we indicate this or calculate this using code? So if we carefully look at the top pointer, it is pointing towards which index? Towards the second index, and which is nothing but the third element. So since this is a zero based indexing, this is a 2 plus 1, which is the third element. So this essentially gives us the size of the stack, right? So if we are at, let's say, index 4, so we can simply do return a top plus 1 for the size. So what this will return, the top is 4 and 4 plus 1 is 5, so this will return a 5. So at this particular instance, we are saying that the size of the stack is 5. And if we check, we have 1, 2, 3, 4, and 5 elements. So yeah, the size is indeed 5. So this will be the size operation. So like this was all about the various operations, like how will we do them. So now let's just actually jump upon to the code of it. Like how will we actually be implementing? I'll be writing the code, and then I already explained to you the logic behind it. So let's just write the code so we can simply understand it better. So, so this is the basic boilerplate. Like we have the hash include IO stream using IMSI standard int main return 0. I hope you all are familiar with this in the C++. I'll just make it a little bit bigger so that it is clearly visible. And now we have to declare a new class called stack, right? And in this class, what I just said, like how are we implementing stack? So we are implementing stack basically using two things: a dynamic array, and a top pointer, right? So these are the two things which we require for the implementation. But since these things are internal, we want these to be hidden from the user. The user should not have access to the array or the pointer, because if he does, he can simply do something like, if let's say our array is this, we can do something like array at 4 and access the element at 4, irrespective of the fact that the top may currently be at the sixth index, right? So if the top is at the sixth index, and then the user should not be able to access the fourth index, because as I said, the element should only be accessed via this top pointer. So keeping that in mind, what we have to do is we have to make both of them as private, like the array also as private. So like the array will be what it will be. Let's say we are implementing a stack of integers, so it will be of type int star, right? Since it is a dynamic array, so it will be a pointer which will be pointing to the first element, so int star arr. And the second, we have a simple pointer which will be always of the type int, irrespective of what the array is, because this is pointing to the indexes. So even if the array is of type char, so if the array is of type char, this might be a char star, but for now it isn't. But this particular top pointer will always remain int, because this is essentially accessing the indexes of the array 1 2 3 4 5 6, and basically 0 if the indexing is 0 based. So this will always be an integer, right? The indexes. So this will be of type int. And now we have to make some public methods through which the user can access actually these the stack which we have. So these methods will be accessible to the user. So first of all, we have a constructor for our stack, where we do nothing but we just like construct the array. So like the array would be a new int of size capital N, let's say, and let's say we just declare this this n beforehand. So we use a hash define n, and let's go have this of size 10 for now. This means that we are allocating a dynamic array of size 10, and the top will be initialized to -1, as I said, because the array will be initially empty, or the stack will be initially empty. So the top will be initialized to -1. And one more thing, that like I have mentioned private over here specifically. So if you are in Java, I guess there you have to mention this specifically, but in C++ you don't need to write private. Like if I just delete this, by default the things which don't have an access specifier are private in C++. So yeah, so these both will be private. So this was just the initialization of our stack, and now we actually define some methods. So what were those methods? So the very first method which we talked about was a push, the push method, right? Or the push function. But just think, what will be the return type of this function? So while pushing, are we returning something? No, it is just a void operation, right? So the return type will be void, and it has to take an argument as an integer, since the stack which we are implementing is an integer stack, or a stack of integers. So like we just take an argument of an integer x. So x is nothing but the element which we want to insert into the stack. And what we just discussed, like before doing a push operation, we have to do an if condition, like check if the top is already equals to n minus 1 or not. Like if the top is already pointing to the last element of the array which we declared. So if that is the case and we are trying to do a push, so we should not be able to do that, and this will essentially throw an error known as a stack overflow error, right? And we'll simply return from here. Else, if this is not the case, like we have some space left in our stack, so what we'll do is array at plus plus top equals to x. So what we did was we first incremented the top. The pre-increment implies that the top is incremented first, and then we access that index, that particular index which the top pointer was pointing to, and then we changed its value to x. So if this is difficult for you to understand, you can also do simply something like top plus plus, and then array at top equals to x. So the whole idea is like we have to increment the top first, and then we have to change the array element or something like that. So, yeah. So this was about the push operation. And the next operation which we talked about was a pop operation, right? And what would be the return type of pop? Again, it will be a void because we are not returning anything, and it does not have to take any arguments because while popping we don't need any arguments. And if again we have to check if the top is already at -1, so and we are trying to pop, then there will be a stack underflow condition or a stack underflow error, right? Or you may also simply print something like stack, the stack is already empty, something like that. It depends upon your choice what do you want to display. I'll just display a stack underflow, and after this we'll just simply return from here. But if there are some elements in the stack that, like, the stack is not empty and the top is not equals to -1, so what we'll do is we'll simply do a top minus minus, like decrement the top. This is how we discussed, like we pop the elements, right? So push pop, and the next operation is what? The top operation. So the top, I'm like making the T as capital T because then this top pointer and this top function will have the same name and it might lead to some sort of errors. So like this is a top operation, or if you want you can even call this as a peak operation, but I'll just call it as a top. So in Java it will be peak. So yeah. And what is the function of this operation which we just discussed? That it returns the current element which is being pointed out by the top pointer. So the return type will be an integer since currently we are working with a stack of integers, and we don't need any arguments because we are just accessing the top element. And again we have to check if the stack, like we are accessing the top element, and we have to check that if the stack is empty. So how do we check that? So if the top equals to -1, then we cannot access any element, right? Because there are no elements in the stack, so what will be accessed? So again we see out the same thing, like this time I'll write stack is empty, something like that, and we'll simply return. So like, and now since the return type is an integer, so we have to return some value. So let's say I'll just return a -1 over here, so we can do that. Or else, like I'll just tell you, like if the thing is, here we are returning the array at top, right? Because we wanted to access that element which is going pointed by the top, which is nothing but the array at top, so we are returning this. So even if we don't do this, and if we hit a condition where top equals to -1, so it will do nothing but return some garbage value. So it's up to you if you want to return a -1 or a garbage value. So for now we will not be returning a -1. We'll just work our way through the garbage value. You'll get to know why I am actually doing this later in the video. So yeah, follow along. And the we did with the push, pop, and the top operations. So the next operation which we want to implement is nothing but the empty operation, which was of type boolean as we discussed. So bool empty, and again we don't need any arguments. So here we simply return whether we check whether the top is -1 or not. If it is -1, like if this condition is true, so it will return a true. If this condition is false, it will return a false, and it will tell us whether the stack is empty or not. And the last thing which we discussed was size. So it will again be an integer because size always, it has to be an integer. And again it does not need any argument. So what we'll simply return over here is top plus 1, right? Because since the top is a pointer which is following a zero based indexing, so the top plus 1 will give you the size of the stack. So yeah, so I guess we are done with implementing our complete stack. So yeah, if you want to see everything at once, there we have. So what we did initially was we declared two things. The first was a dynamic array, and the second was a top pointer using which we were accessing the elements of the stack, or through which we were actually implementing the stack. And then we just initialized the stack using a constructor where we declared this array of n size. We allocated memory to this array pointer, and then uh, we initialized the top to -1, and then we implemented all our functions like the push, pop, top, and empty and size. So now how do we access this? Like how do we declare a stack? So we simply do nothing, but since the class is of type stack, like a named stack, so we'll simply create an object of the class, an instance of the class. Let's call this st. So we have our stack with us. So now, like, see, if we now do a dot, we how do we access the different functions of the class using a dot operator, right? So if we see a dot, we have this. We have our push, pop, top, empty, and size. We have these 5 options. The user has these 5 options with him. So let's say we push some elements. We push 1, and then I pushed, let's say 2, then 3 into the stack, and then 4 into a stack, right? So currently how the stack will look like. So like we discussed, it follows a LIFO order. The LIFO order is last in, first out. So the last one is 4, so it will be 4 first, and then 3, and then 2, and then 1. So the stack will look something like this, right? And now let's say we try to access the top element of the stack, which is nothing but 4. So we just print that out. See out stack.top and then, and now we pop up at this particular element, like the 4 is gone from the stack. And let's just repeat it a couple of times. So again, this time we print 3 and then pop this 3 out of the stack. We are on 2. So we did do this again. The 2 is gone, and we print this 2 and then we pop this 2 and we are on 1. So again, we print this one and if we pop this one, and at this instance the stack is empty, right? So we just can perform our operation of stack.empty to check whether the stack is empty or not. So this will, at this particular instant, this will return a true, which will be nothing but a 1. So just to differentiate and make things clear, I'll do it this in this manner. If stack.empty, like if it is 1, so this if condition will be executed. So I'll just see out a true, and else I'll just see out a false, which means the stack is not empty, right? So what should be the output of it? So at this particular point we should print a 4, here we should print a 3, here a 2, here a 1, and here we should get a true value. So let's just like a capital T. So let's just see if that's the case. I'll just run this particular program, just make a new test case and run. So yeah, so you can see that we are getting 4, 3, 2, 1 and true. So the output is as we expected it to be, right? Okay, so now now let's suppose the stack is empty, and let's just check all these conditions, like the stack underflow condition as well. So where do we get this condition? Like if we try to pop again, right? Let's just try to pop again. Let's say if we try to perform a pop operation again on the stack, after the stack is empty, what happens? You get a stack underflow error, right? Okay. Now let's say we had the stack of size just instead of 10, we had the size just 4. Or maybe let's say we had the size as just 3, right? And we are pushing 4 elements into it, like 1, 2, 3, and 4. So at this particular instance, the fourth element, what we'll get is a stack overflow error. And then these will change accordingly because the stack size has been reduced. So let's just run it. And here you get a stack overflow error, right? Uh, so yeah, so this was all about the basic operations of the stack. And here also we are getting some garbage value. Why? Because we didn't return -1 over here. We are trying to access the top and we are returning array at top. So array at -1 will be some garbage value. All right. So yeah. So this was all about the basic operations and how do we implement stack using array. So now let's do something extra. Like these things you can get in other videos as well. So what is unique with our video? Or why do you want to watch this video? So let's say you are in an interview and you land upon a question uh, where you need to use stacks. So what we generally do is we use a stack STL, a standard template library, or a collections framework if you are working with Java. So let's see what that is. So let's just comment this out for a moment, and let's include a stack header file which contains the stack STL. So what we generally do is instead of declaring a stack like this stack ST, we also have to specify what type of stack do we want. Like should it be a stack of integer or a stack of characters or stack of string? And then again we have these all these operations are same. Like this top is not t, this is small t I guess. So if I just do dot, so yeah, we have this small t. So this will work again, right? Okay, like this is giving me an error because I have to change all that capital T's to small t. Because in the STL they are using a small t. Maybe they are naming the top pointer as something else, so that's why. Yeah. Now if I try to run this, okay. Uh, what is this error? Okay, let's just try to write it again. So if I just push in an element 1 and then push in an element 2 and then push an element 3 and so on, and then let's say I just want to get the top element which will be 3 at the moment. And if I run this, what is the issue with push? Why is it giving me an error? Okay, I declared the stack as a string, right? It has to be an int. I'm sorry, really sorry for that. So yeah, yeah, there we go. So now if we try to run this, we'll get the top, which will be 3, right? So like, let me just get all all of those back. Yeah, there we are, and we changed everything. And this is not a string; this is a stack of integer at first. And now if we try to run this, we'll get the similar output like 4, 3, 2, 1 and true. Right? We got the same output. So this is how you generally use an STL, the standard template library of C++. So this is how we will be doing it when we will be solving questions. We won't be every time implementing our own stack. But let's suppose in an interview, you are asked to implement your own stack and you want two instances of that stack. So like one instant has to be a stack of type integer and or int, and the second instance has to be a stack of type, let's call it a char. Okay, so let's say it is a char st, like a stack of character. So we won't be able to do it like in this way, right? Like if we uncomment this again, and let's say the size is 10. So, and let's just remove this header file, which is STL, because we are not allowed to use the STL in the interview. So now how will we generalize this? Like we don't want to make every time classes of different types. Like, in this one I used a stack of int, so I'll name this class as stack int and then stack char. So we want this particular class itself to handle all the types. So this is where comes into picture a feature of C++, which is called templates, which is there in Java as well, I guess. So you can check it out. What is it? How is it exactly implemented in Java? But we'll be discussing C++. So yeah. So this is done nothing but by template, and we write a class and T. So what this means, or what this does, in short, is that this T can take any input and it will adjust itself according to that. Like, let's say if you are specifying something, if you make stack at int, so this stack of int, so this t will be converted into an integer. If you make it a char, so this t will be converted into a char, and it will adjust itself according to the data type which you are passing. So instead of uh, making a specific type of stack, which is a stack of integer, what we can do is use this template and replace everywhere where there is an int with a t. But we have to be careful in that as well. Like the stop will always be an int, because this is basically what, a pointer which is pointing to the indexes, right? So yeah, 0, 1, 2, 3, 4. So this will always be an int. But this int star array, this might be a char star array, this might be a string star array, it can be anything, right? It might be a float star array, a double star array, anything. So this will make it as t star. So t. And now here also, it is not an integer. We are not declaring an like allocating memory for just for integers. It can be anything of type t, a generic thing. And when we are pushing as well, we can push anything. So this will be t as well. So where else we have an int? So in pop it is all fine. So in top, this can again be a t. And this is why I stopped you from returning a -1, because -1 is very specific to integers. So over here, like, you cannot return something like return t. This won't give you an error. So instead of that, what you can do is just ignore this. So like whenever you have some error, as you will get this message as stack is empty, and then array at top will give you some garbage value. So yeah, and then the empty will always be of type boolean, because it is always either a true or a false, and then the sizes will always be of type int, because this is nothing but the size of the stack, right? Okay, so this is how we implemented our general stack. So now if we want to declare it, instead of just writing stack st, what we'll do is write a stack of int st. So now we know that this stack is a stack of integers, and if we now run this, it should work fine. Okay, we are getting an error again. So let's see what the error is. Stack.top. Okay, again, like we have to change. We declared this top as capital T, and we are using small t here. So we have to change this to be capital T everywhere. Yeah. So now if we run this, it should work fine. Yeah, so it does work fine. And this is a stack underflow because we popped again at the right at the end. So yeah, if we remove this, it should again work fine. So yeah, it does. So instead of now int, we can also change it to a char. And instead of 1, 2, 3, 4, what we can do is we can insert an A, B, C, and D. Right. And now instead of 4, 3, 2, 1, this will be DCBA and again a true. So if you run this, yeah, this is the CBA and again a true. So similarly, you can also make it a string, like anything you can do. STG, let's say, and AFV, anything, any random thing I'm writing. ASF and SFA, and you can make it a stack of string as well. And if you run this, we again get our output like in the similar fashion, like SFA is first, ASF is second, AFV is third, and STG is fourth. So whichever came last in was the first to be printed out or to be popped out of the stack when we did this pop operation, right? So, and again, similarly, you can make it a float as well if you want. It's up to your choice. What do you want to use this as? So in this fashion, we can actually implement the stack STL or the stack collections framework in Java. Uh, you know, like in an interview, if you are not allowed to implement an STL to solve the problem. So yeah, that's it for this video. I hope you enjoyed. Uh, and if you did, let me know in the comment section below. So thank you. Catch you up in the next one. In the next video, we'll be seeing the linked list implementation of stacks.